Welcome to episode 47 of the ongoing AS and A-level Java series, and in this episode we're going to be looking at exceptions in Java. Alright, so to get us started, let's actually create a main method. Then I will just demonstrate the concept of an exception. So let's create an array of numbers. Then we are going to have initialize it with maybe 4 elements, so 1, 2, 3 and 4. Alright, so by default our array elements have index positions 0 to 3. Alright, so in order to access a particular element, we need to make sure that our index positions are between 0 and 3. But what I'm actually going to do is I'm actually going to deliberately provide an array index value that I know is out of bounds, as it were, or it's not in range for a given array. So maybe I'm going to put 5. Right? Then I'm actually going to try and print out the 5th element, or the element that is index position 5, even though I know that I do not have such an element. So let's just go ahead and run this, and we should see that we get this exception here. So it says exception in thread main java.lang array out of bounds exception index 5 out of bounds there. Alright, so that is an exception. An exception is just a fancy term for an error. So as you are writing your programs, you realize that you oftentimes want to create a program that is robust, or a program that is fault tolerant. For instance, a user might try to input a string when the program expects them to input a number, and in such cases you do not want to have your program crash. You just want to make your program continue running, and in the event that a user does something that's not expected, or maybe something unexpected happens, you just want to be able to handle that situation and carry on with the program. You do not want your program to crash. Otherwise it wouldn't be desirable in most cases, because you realize that some programs, they are mission critical, and you just want to quickly consume or quickly deal with errors and allow the program to continue running. So let's actually go ahead and see what we can do in order to handle that kind of situation, or how to handle exceptions. So I'm just going to cut this code. So Java is something that's called a try-catch block. Right, so what a try-catch does is that it has 2 statements. It has the try keyword and the catch keyword, and in between each of the words you have the body, or you have the curly braces. So you see right here on the try, it starts on line 4 and ends on line 6. Then the catch is right here on line 6. Then the catch now, it's different from the try in the sense that it's actually going to have parentheses. Then within the parentheses, you're actually going to instantiate an object. So we are going to take the exception class, which is found in the default Java API. So you can see that it's found in the java.lang.exception. So basically this is a class which allows you to handle errors. Then after which you create an object. So the object that I create in this case is just called E. So it's an exception object. Then inside of the catch, you're going to have another set of statements, right? Inside of the try, you can have a set of the first set of statements. Then inside of the catch, you can have the second set of statements. So the statements that you would want to put inside of a try are the statements that you suspect might cause an error, right? Statements that you might suspect may cause the program to throw an exception. That's what you put inside of the try. Then inside of the catch, basically catch simply means that in the event that my program throws an error, or it throws an exception, you basically want to catch it, or to handle it in a certain way. So in our case, we simply want to maybe say sysout, then say there was a problem accessing the desired element. So that's what we want to tell the user. In the event that our program runs into a problem, we simply want to handle that, or to catch that error and display the message that there was a problem accessing the desired element. So let's actually go ahead and run this and see what we get down there in the console. So you see that this time we get this nice message which says there was a problem accessing the desired element, right, which is more helpful, unlike in the first instance where we had a very long error that would be not so friendly for non-programmers. So you can also make it you can also have a very useful message, like maybe in this instance let's actually have another system.out the print line statement. Then within here what we can do is, remember we created this exception object, is it? So what we can do, making use of that exception object, we can then have access to methods that are built within the exception class, as it were. So since we've instantiated an exception object, what we can do is we can now have access to all the different methods that we have, and there's one in particular that is very useful, which is called getMessage. So getMessage basically returns a string, or it returns the exception or the error as a string. So you can actually use that to even add more detail, or even to help the programmer understand even more what the problem was. So if we go ahead and run this, you'd realize that we get this index 5 out of bounds for length 4. So this is now more helpful, especially to programmers who would be trying to debug or to solve the exception that might have occurred within the program. Then one more thing that we can do is we can actually have another, so the try and catch, you can end it like this, right? This is okay. But what you can even do further for some applications, like maybe let's say for instance you are creating a database application, right? So what you're going to do is you're going to try and establish a database connection within this try block, right? And in the event that maybe say the information that was out input by the user, we cannot directly take it to the database because maybe it has some missing values, is it? So what you can do is you can then catch that exception, or throw the exception and display a message, right? But you'd realize that maybe later on the database connection is still on or still open, as it were. So you want to close the database connection. So you need to have some sort of way to handle or to run your code no matter what happens, whether you got the correct values to store in the database and you didn't have an exception, right? You still want to have a way to close the database connection, just as an example really. So what you can do is you can make use of the finally keyword. So finally what it does is that it's actually going to have statements that you want to run no matter what happens. So what we can do in this case is we can just say this will run irregardless of what happened. Some like to say regardless, or some like to say regardless, it's still the same thing. So this will happen regardless of what happened, right? So let me just go ahead and run this, and you see what we get down there in the console. Let me just put a couple of full stops here. All right, so let's run this. So you see that there was a problem accessing the desired element, so index 5 out of bounds for length 4. Then this will run regardless of what happened. So the code that you put inside of a finally block is actually going to run no matter what. Like for instance, using the database example that I highlighted earlier, maybe you want to close the database connection, you can actually still do that. Maybe even if I were to put an index position that I know is valid, like 2, go ahead and run this, you realize that this time around the catch block didn't run because we didn't have an exception, or we didn't have an error. But the program actually gave me the value of what? The value of 3, or the element 3. Then it went on to just run the code that is within the finally block. So that's how you can make use of exception handling using a try and catch block, then the optional finally block as well. Then one more thing that I should demonstrate is that you can also create your own you can also throw your own errors, or you can also throw your own exceptions. So maybe what I can do is, let me just create a public static void method here called validate edge. Then it's going to have a local variable called edge as a parameter. Then I'm actually going to have an if statement that checks to see if age is less than 18, in which case I want to throw a new arithmetic exception. Then I simply want to tell the user that access denied, you must be 18 or older, right? Otherwise I just want to say maybe let's say the user is older than 18. What I simply want to do is I want to say sys out, then I just say access granted. So that's all I want to do, right? So maybe the thing that I need to show you right here is the throw new, then the class that you want to throw right here. So this is how you can create a custom exception within your program, right? Instead of getting the default exceptions, you can actually create your own exception by using the throw keyword. So what's going to happen when you call this method, right? We are going to pass it an argument. Then that argument is going to be checked to see if it is greater than 18. If it is greater than 18, then we are simply going to run this else statement, the code that is beneath this else statement. But otherwise, it's actually going to throw what? The arithmetic exception right here. So let's just go ahead and run that within the main method. So let's say validate age, and maybe let's put 15, because we know that 15 will actually give us an error. Save and run. So you see here we get what? Exception thread in that arithmetic, right? Exception access denied. So that's how you can throw an exception, is it? Then what we can do is maybe let's just go ahead and call it one more time, but this time let's pass it an argument that is valid. So let's put 85 there. Maybe I'm just gonna go ahead and comment line 14, so that this time around we just run with the validate age of 85. Then you see that it says access granted, right? So that's how you can go ahead and create your own custom exceptions, as it were. And generally that's how you can also handle exceptions in Java. So I think that's just about it for this episode. I'll see you in the next one.